Hello, and welcome to the Body VR, an immersive tour through the human body.
Yes, hello everyone, and welcome to the Body VR. I'm gonna reorient really quick.
Resetting orientation in 3, 2, 1.
There we go, okay. This is so I can talk straight to you guys. I just loaded up this game. I have no idea what I'm going to see, but I'm gonna guess, yes, that is the day and time I'm recording this. I have no idea what of these I'm going to be looking at, so let's just go ahead and get started, because I am interested.
Our journey begins
It's always been a fascination.
inside a blood vessel, carrying blood from the heart. Let's take a closer look.
So we get to go into a spacecraft. Interesting. Oh, seriously? Okay.
We are currently inside an arteriole, a small strand in a network of blood vessels that spread throughout the body.
Right.
Let's take a look at the blood's most prominent cell, the red blood cell. Red blood cells, or erythrocytes, take up almost half of the blood's total volume, giving a red colour to our blood. Their main function is to transfer oxygen from our lungs to vital parts of our body.
Okay. Interesting so far.
Next up are white blood cells, or leukocytes, which take up less than 1% of the blood's total volume. Their main function is to protect our body from infection. Lastly, let's examine platelets, or thrombocytes, whose main function is to stop bleeding at the site of a damaged blood vessel.
These guys?
On our right, you can see a tear in the blood vessel. Let's investigate.
Yes, let's please investigate. Okay. Oh, that's disorienting.
A type of
Whoa.
leukocyte, the monocytes, creep through blood vessels to become macrophages and search for foreign invaders, which they eat and digest. Let's lead the bloodstream through the tear to find a macrophage. We must now undergo further miniaturization.
Whoa. Okay.
We are currently on the outside of the macrophage, within an infected tissue, looking at its surface. A typical cell membrane structure. There are thousands of receptor proteins on the surface of the cell. Some of these proteins are tasked with transferring information, and others with transferring cargo. Water and oxygen pass freely through the cell's membrane.
Oh, that's what that is. Water!
Larger molecules, like glucose, enter through small pumps or channels.
That is so weird to be
Large
holding.
objects, like viruses, require recognition or keys to gain access, thus preventing unauthorized entrance. Fortunately, I have a counterfeit key that's identical to a real one. We are now entering the cell.
Oh, so we're just getting smaller and smaller. This is gonna be fun. Come on. Oh, wow.
A macrophage
Oh, that
has
throws me
pulled us
off.
in, and we are submerged in the cytoplasm, a gel made mostly of water. The cytoskeleton is made up of a network of adjustable strands that gives the cell its structure. There are 3 different types of strands that make up the cytoskeleton. Microfilaments are the thinnest strand, measuring only 7 nanometers in diameter. Intermediate filaments are made of the protein actin and have a diameter of 10 nanometers.
That is tiny.
Lastly, microtubules have a diameter of 24 nanometers, which is wide enough to be used for transport.
That ain't fair. Glitching out on me. What is that?
A special type of protein, called kinstin motor protein, has the ability to walk along microtubules. It latches onto larger structures and transports them around the cell. Energy is available in the cytoplasm in the form of ATP molecules. ATP binds with kinstin and propels it forward. With each step the kinstin takes, it binds with an ATP molecule and releases an ADP molecule. In real time, kinstin walks up to 100 steps per second. The kinesin protein is heading straight for the cell's nucleus. Let's tag along for a ride.
What? Oh. Okay. That is so
We are
weird.
now approaching the nucleus, the center of the cell.
It looks like a big nuclear reactor.
The surface of the nucleus has its own membrane, similar to that of the cell. Pores are spread around the surface of the nucleus to allow entry and exit of larger molecules.
That guy.
Protein filaments are located around the edge to facilitate the transport.
Oh, that's so weird. I'm at you. That looks good. I don't know. Holy crap, that is so weird.
Let's head inside.
Holy, that is weird. It's just like right in front of your face. That's how it's supposed to be, but still.
Here we are inside the nucleus, the control
DNA.
center of the cell, containing the majority of the cell's DNA. DNA, or deoxyribonucleic acid, is a molecule that carries our genetic code.
That is
The
so
DNA
cool.
contains instructions for protein synthesis. process of transcription, a segment of DNA is copied into RNA or ribonucleic acid, containing a single recipe for protein creation.
So yeah, there's your difference. I mean, given you can look just right at these and see the difference. Oh, jeez.
Let's exit the nucleus through a nuclear pore.
I looked up and saw a big hole. I don't know why that spooked me like it did.
We have exited the nucleus and are now floating through the cytoplasm. Surrounding the nucleus is the rough endoplasmic reticulum, or RER, a maze-like structure made of flattened membrane. Studied with ribosomes, the RER maintains a vital role in protein synthesis. Ribosomes link together amino acids, following the instructions received from the RNA. The protein is then transported in a vesicle made from a portion of the RER's membrane. In the distance, you can see a mitochondria. Mitochondria are free-floating organelles, typically referred to as the powerhouse of the cell. Mitochondria received its name due to their vital role in ATP generation. ATP, or adenosine triphosphate, is the main source of energy within the cell. Mitochondria take the pyruvate and convert it into carbon dioxide and water, releasing ATP in the process. Now that we have seen the major components of the cell, let's make our way outside.
Oh, so we're getting bigger again? Okay, that works. I'm enjoying this. This is kind of cool. Bye.
What is that?
Good question.
There's an incoming virus attack headed for the cell.
Oh boy.
Fortunately, a cloud of antibodies is stationed around the cell to protect it from viruses.
These are just like coming right at me.
The white blood cells consume the viruses as they are highlighted by the antibodies.
Just open fire.
Together, the antibodies and white blood cells form the front line of our immune system.
They keep coming straight at me.
Thousands of viruses have made it past the antibodies. The viruses overcome the defenses, and some viruses are able to enter the cell using counterfeit keys.
Am I able to see a demonstration of said counterfeit key?
Many viruses. It looks like the cell is not going to survive. Let's head back to the observatory.
Does this thing actually deflect them? Oh, it does.
It's our journey through the human body. We hope
Really?
you enjoyed the tour.
That's it? Oh, okay, I guess that's it.
Hello,
That was
and welcome to the Body VR, an immersive
Somewhat.
tour through the human body.
uncheck them all. Okay, well that was fairly interesting. You get to see roughly how everything works on the microscopic level. So, alright, well, I do thank you guys for joining me on this endeavor, this journey through the body VR experience. I will cut it here, and I'll see you guys in the next video.
We gonna rock, then we gonna fall, then we let it pop.